In a world where most hypercar brands are moving towards massive turbochargers, Bugatti went in the exact opposite direction. They built a mechanical paradox for the new Tourbillon, an 8.3-liter naturally aspirated V16 with absolutely no turbos. This engine breaks every rule of modern engineering. 16 cylinders and a red line screaming to 9000 rpm. But generating extreme power without forced induction means the engine has to spin insanely fast, and that creates a terrifying problem. The answer lies inside the architecture. The layout is a true V16 consisting two banks of 8 cylinders arranged in a V shape that spreads wide at a 90-degree angle to keep the center of gravity low. All 16 pistons share a single die-forged steel crankshaft which is exactly 39.3 inches long. At low speeds that is manageable, but at 9000 rpm it becomes an absolute engineering nightmare. A shaft that long doesn't just spin, it flexes, it twists. Every time a cylinder fires, it sends a shockwave through the metal. If those forces do not align perfectly, they create torsional vibration, a harmonic resonance so violent that it can snap the engine in half instantly. To survive this, Bugatti broke their own rules. For the very first time in history, they outsourced. In 2021, they partnered with Cosworth, the same engineering team behind the screaming V12 in the Aston Martin Valkyrie. Given a blank sheet of paper, Cosworth delivered a physical prototype in just 13 months. Their solution wasn't just stronger metal, it was pure mathematics. They calculated a firing order that doesn't just eliminate the stress, it distributes it. Each combustion event is perfectly timed to cancel out the shockwave of the previous one. But because there are no turbos to provide the initial acceleration, Bugatti integrated three separate high-performance electric motors powered by a 24.8 kWh T-shaped battery integrated directly into the chassis. Two motors are mounted on the front axle, with the third integrated straight into the rear axle. These motors were engineered by Rimac Technology, the absolute pioneers of EV hypercars. Using the DNA from their record-shattering Nevera, they designed an ultra-dense 800-volt system where the electric motors can spin up to a blistering 24,000 rpm. Together with the naturally aspirated V16, they push the total output to a staggering 1800 horsepower, 1000 from the V16 and 800 from the motors. The old quad-turbo W16 from the Chiron Super Sport made nearly 1600 horsepower on its own. So, why Bugatti didn't just bolt these three electric motors to the existing W16 to create a 2400 horsepower monster? The answer comes down to three strict limits of physics. First, packaging. The old W16 is incredibly wide and boxy. By switching to the slender 90-degree V16 layout, Bugatti freed up the crucial lateral space needed to run high voltage cabling and massive cooling ducts along the sides. They also moved the transmission to the rear of the car, making room for the heavy central battery pack. Second, the thermal sealing. The old W16 was a literal furnace that required 10 radiators and pumped 800 liters of coolant per minute just to survive. High-performance batteries and electric motors generate their own massive thermal loads. There isn't enough surface area in a hypercar to cool a quad-turbo W16 and a hybrid system simultaneously. Third, the law of diminishing returns. The W16 engine alone weighs around 400 kilograms. By dropping the four heavy turbos, the new naturally aspirated V16 saved off nearly 150 kilograms. That exact weight savings allowed Bugatti to integrate the heavy battery pack and electric motors without turning the chassis into an uncontrollable beast. But here is a catch. After all this integration, the weight savings, and the absolute engineering mastery, the new Tourbillon is actually slower. The legendary Chiron Super Sport shattered the 300 mph barrier. The new Tourbillon tops out at around 276 mph. But Bugatti didn't build an entirely new, wildly complex V16 to chase top speed, because top speed is a vanity metric. Extreme engineering is about absolute launch dynamics. The electric motors handle the brutal low-speed launch, providing instant torque, and the naturally aspirated V16 takes over as the speed climbs. That instant electric punch doesn't just beat the old Chiron's mind-blending 0 to 60 time of 2.4 seconds. It entirely eclipses it. The new Tourbillon hits 60 in around 2 seconds. The decision to abandon the W16 wasn't a step backward. It was a calculated masterstroke in the power density. By trading heavy turbochargers for a high output electric system, Bugatti achieved superior mass centralization and brutal instant torque. It proves that the future of extreme engineering isn't just about straight line speed, it's about absolute system optimization.